Hello, everyone, and thank you for joining us today for PractiTest webinar series. We're very, very happy to have, is it okay if I call you Rob? The official Rob or Rob?
Oh, no, definitely not. Definitely no.
Not.
Yeah, please,
okay.
please. No, I'm joking. Please call me Rob. Yeah, my wife calls me Robert, so call me Rob.
Oh, okay. No, so
everyone calls me Rob except for my wife.
So today we have Rob Meaney with us. I will give him the honor to introduce himself in just one more seconds with this very big title that got a lot of your attention, where testing is not the goal. I'm going to give one short slide about PractiTest for those of you who do not know us, and you should. We invite you to. So PractiTest is an end-to-end application lifecycle management with the aim to incorporate all testing elements in one central platform. We integrate all types of testing, manual, exploratory, and automations from any type of tool into our test management platform in order to generate visibility and confidence in testing results. You can see, I'm not going to read for you, of course, so you can see a very nice quote that we take a lot of pride of from Sari Tallinn from Nets, which basically describes the benefits of working with the test management when it works as it should. We are based in Israel, as Rob mentioned, but we have customers in more than 55 countries today, which is nice. That's a nice number to throw in the air, but also a real one. And one last pride, we're a cloud solution, a leader in the G2 quadrant by actual user reviews. So if you're not familiar and you are in the market for test management platform, be sure to check us out. We are SOC Type 2 compliant, obviously comply with GDPR and ISO 27001. And basically, any level of certification and compliance that a cloud solution should have those days. And without further ado, because you're here to hear Rob, I'm going to stop sharing my screen and hand the mic.
Baton to me, is it? Yes. Cool. I'll start sharing my screen and I'll do a little intro for myself. I usually don't do it, so I'm winging it this time. My apologies, and I will put this. So you can see my screen, I assume. Fantastic. So yeah, my name's Rob Meaney. So I'm Irish. You may have guessed maybe from my accent. And currently I'm working as Director of Engineering with a company called GlowFox here in Ireland. So we work in I suppose the fitness domain. So we provide a platform for fitness entrepreneurs that allows them to do everything around acquiring members, managing them through their entire life cycle, booking classes, buying memberships, all that kind of good stuff. So I head up a team of an engineering department of about maybe 50 or so people, working in test development, design, PM, all that kind of good stuff. So yeah, so the talk, testing is not the goal, so I'm going to go for it now. I've done my little intro and I'm going to get into the talk if you don't mind. So the most profound lessons I've learned in my career have come from the most painful experiences. Imagine for a moment sitting with your development team at the company all hands and listening as your CEO tells the entire company that the product that you've been working on for the last 3 years is a failure. 3 years of blood, sweat, and tears, all for nothing. It's hard to imagine anything more wasteful, more soul-destroying than seeing your team pour their heart into building something that ultimately nobody wanted. But this experience isn't unique to us. Research suggests that upwards of 2/3 of all software initiatives either have a negative effect or no effect at all on the key metric they were supposed to impact. This research suggests that optimistically, you and I are spending 2/3 of our time building, testing, and maintaining software that nobody wants or needs. So Amazon, by the way, had the highest success rating in the industry, achieving a rating of just 50%. So even the best in the industry are still wrong half of the time. So although painful at the time, reflecting on this experience taught me a valuable lesson. Our ability to deliver valuable software was constrained by just 2 things. Firstly, and most importantly, our ability to manage uncertainty, or in other words, our ability to learn. And secondly, our ability to deal with complexity, or in other words, our ability to adapt our systems safely based on what we had learned. So first and foremost, we failed to learn what the right things to build were. But secondary to that, we also failed to learn better ways of building the right things. Building the wrong thing better wasn't going to solve our problems. So by the time we had eventually learned what the right things to build were, what the customers actually needed, we had created an unmanageably complex system that we couldn't safely adapt based on what we had learned. We found ourselves overwhelmed by technical debt and quality issues. And ultimately, it was this inability to learn and adapt our systems safely that killed our product. So in stark contrast to what we had experienced, the most successful companies in the world today have weaponized learning. Their ability to learn faster than the competition is their competitive advantage. Amazon is maybe the best example of this. Werner Vogel, Amazon CTO, claimed that Amazon did 50 million deployments in 2014. That's more than one deployment per day. And every single one of those deployments allowed them to learn something about their customers, their systems, or their ways of working. Imagine how quickly Amazon are learning today in 2021. So Amazon have had to evolve their practices to manage complexity at a staggering scale over the last 20 years. In order to simply survive, they've had to purposely design their systems to deal with mind-boggling complexity. They've had to design their systems and ways of working so that teams can focus on just their tiny, minuscule part of the overall system. So in the early 2000s, they pioneered ideas like the autonomous two-pizza team, service-oriented architecture as a service, and so on and so forth. And it's this single-minded focus on learning and managing complexity that has allowed companies like Amazon, Google, and Netflix to become some of the most successful businesses in the world. This focus allows them to move with speed and safety at scale. So we've just heard what happens when we fail to learn. What happens when we fail to manage complexity? So why not ask the smug kid in the right in this picture? That's my son, Adam. And for a 24-hour period, a couple of years ago, while we were in England visiting Legoland, he was the richest person in our family. Why? Well, Visa had a European-wide service outage that meant we couldn't withdraw any cash. And so Adam, with a sum total of £45 in his little Velcro wallet, was now our chief holiday financier. And for a moment, I panicked as I tried to figure out how we were going to pay for food, transport, and accommodation in a foreign country without access to our bank accounts. It was a situation that made me acutely aware of how dependent we've become on software systems and how utterly vulnerable and helpless it can make us feel when they don't work. But it also made me think about the teams of engineers that were scrambling in the background to resolve the issue. I've been there myself. I could almost feel the stress, the pressure, and the subsequent shame that they would have to endure. Within minutes, the outage was plastered across social media, and within hours, it was all over the mainstream news. I could almost hear the blame-laden questions being asked by senior management. How could this happen? Why didn't you test this? But without adequately managing complexity, our systems will fail with horrible consequences. And there are real costs to software failure, financial and human, for both our users and the people building and operating our software systems. So the question is, how can we deliver value to our customers quickly, reliably, and sustainably when we're working in this increasingly complex world where everything is connected, change is continuous, and failure can be catastrophic? Even though Glowfox is a relatively small company, we find ourselves working with a hugely complex distributed system. We have dozens of interconnected services that are constantly changing and evolving, deployed in a cloud platform, in our case AWS, that we can't rely upon. All cloud providers have outages. And we're integrating against third-party services, like say Stripe in our case, whose APIs and responsiveness can change at a moment's notice. So in contrast, when I started in the software industry, probably 15 years ago at this stage, we had these all-encompassing big bang releases of a monolith. And when it went wrong, it went very, very wrong, and everyone knew. Whereas now we have a constant stream of releases with lots of little failures that may or may not even be noticed. So we have to assume our systems are constantly in a state of partial failure. So this scary new world presents a whole new set of challenges and risks, and consequently requires an entirely new approach to deal with these risks. So we need to unlearn our old ideas about development, testing, and operations, and embrace a new reality in this complex new world. The truth is, our job is no longer finished when we deploy to production. It's just beginning. This is where we really start to learn about our systems and how they actually behave, as opposed to how we imagine they behave. Tests are no longer reality. They never were, I guess, but they're not reality. They're simply our best guess. We need to accept that we can't anticipate and test all the ways in which the system could fail. They're infinite. No amount of testing can tell us what will happen in production. So we need to shift from imagining how our systems will behave to understanding how they actually behave. So we need to accept that failure is inevitable in these complex distributed systems. So in the face of this reality, we need to rebalance our efforts, not just on prevention and detection of problems, as has been the tradition, especially with testers, but on the mitigation and recovery so that our teams can move quickly and safely with justifiable confidence. We need to try to create resilient, anti-fragile systems. So today's high-performance teams have learned to design testability and operability into their systems from the very start as a means to allow them to manage complexity and the associated risks. So managing risk effectively is the key to delivering value to our customers quickly, reliably, and sustainably. Testability allows us to manage the risks we can imagine, while operability allows us to deal with the realities we cannot. So today I'm going to talk you through the journey that has led me to these conclusions. And I'll explore the patterns that cloud native companies like Google and Amazon have learned to adopt over the last 20 years while trying to manage speed and safety at scale. So I'll share 3 career-defining experiences and the associated insights related to managing complex systems. I'll talk about testability, operability, and observability. These insights have helped our teams not just survive, but thrive in this increasingly complex world. So my journey begins about 7 years ago with testability, and forgive the shameless plug for the book that I co-authored with Ash Winter here, A Team Guide to Testability. If you're interested in some of the things I've had to say, you can find out more in the book. So I just joined a US-based hardware company that was building out a brand new software engineering department in Cork in Ireland, where I live. So as part of our onboarding, the whole engineering department was asked to perform regression testing for a forthcoming release. So after 7 weeks, yes, 7 weeks, of torturous regression testing, the release limped out the door. And one of our developers who was acting as architect in the Cork office, Alex, who also had endured the 7 weeks of torturous regression testing, approached me after the release and asked me one simple but profound question. How can we make this software easier to test? So we explored the testability challenges we had faced, and I came up with a model I now call the CODS testability model. So CODS is a mnemonic, And the letters are intended to remind us of 4 important testability attributes to consider when designing our software systems. C is for controllability. And controllability is the ability to identify and control the variables that influence system behavior in order to visit each important state. Next is O, and that stands for observability. The ability to observe and understand everything important that's happening in the system. D is for decomposability, the ability to decompose the system into independently testable components. And lastly, S is for simplicity, and that's what it says, the ability to easily understand the system. So we implemented our design for our first piece of, I suppose, development work that we'd been assigned in the Cork office based on the CODS model that I described. And after overcoming a steep initial learning curve, we began to see truly remarkable results. So let me explore the impact testability had on our productivity as a team. So in my experience, a well-tested system is both checked and explored. Tip of the cap here to Elizabeth Hendrickson's book, Explored. Really, really great book. If you haven't read it, you should read it. So we check to confirm our existing beliefs about the software system, the knowns. Does the software do the things we developed it to do? And we explore to uncover unexpected risks, the unknowns, the problems we couldn't or didn't anticipate and only become obvious through interacting with the software. And by focusing on testability, we improved both the automatability, or our ability to automate checks from a coding perspective to confirm expected behavior. It's great for mitigating the risks we can anticipate, and it also improved the explorability of the product in order to uncover the unexpected or the risks that we couldn't anticipate. So just one long definition I have of explorability is the ability to quickly, cheaply, and safely learn in an unfamiliar situation by iteratively identifying, testing, and challenging our hypothesis. But I have a better definition that's a little bit shorter here. Explorability is the ease with which we can run fast, cheap, safe-to-fail experiments. So exploration is the most effective means of managing situations of great uncertainty or complexity. It's a very human process centered on learning that requires people to use their intuition, their skills and experience to refine their mental models of a system. The idea of explorability can be applied in a very broad sense, but in this context, by making the software more explorable, it accelerates the speed at which we can gain a deeper understanding of how our systems behave and why. So in situations of great uncertainty or complexity, for example, product discovery, testing a new feature, or debugging a production incident, situational awareness is critical. And that is our understanding of what is going on and what is important. Our best approach to gain situational awareness is to explore using small, fast, safe-to-fail experiments. This process can be modeled by John Boyd's OODA loop. The faster we can iterate through the loop, the faster we can learn and adapt in complex, uncertain situations. The first step in the OODA loop is observe. And observe is about gathering whatever information you can about the situation you find yourself in. And the next step is orientate. This is the most human step, right? It's about making sense of or reasoning about the information that you've just gathered through observation and using mental models, expertise and intuition. And this is the most important step. And orientation shapes our observations, decisions, and actions. So then once we've orientated ourselves, we've made sense of what's going on, we decide, D is for decide, we weigh up our options and decide what to do. And lastly, we act on that decision. So then we observe the results of our action and we iterate through the loop again. So when we do exploratory testing, for example, we go through this process, but again, it's used for all exploratory activities, not just exploratory testing. So going back to my story, before focusing on testability, we were in the bottom left-hand quadrant of this diagram. That is, we had a poor understanding of both expected and unexpected behavior of our software. We spent most of our time either manually checking for expected behavior or fixing flaky test automation. We spent almost no time exploring for unexpected risks, which meant lots of problems were going undetected or were detected very late. By focusing on testability, our automation coverage became far broader, deeper, and more robust, checking thousands of attributes in seconds. It proved excellent at detecting bugs and provided almost immediate feedback on every change that we made. This foundation of really great, robust automation freed our testers from having to check expected behavior, so they could now explore for unknowns, the unexpected behavior and risks. We began doing valuable testing that we'd never had time to do before. We began to do deep exploratory performance, resilience, and security testing, and finding new and interesting types of bugs. With both great automation and exploration, the speed, depth, and breadth of our testing was incomparable to before. So this balance between exploration and automation worked perfectly, as automation failures drove action. They provided reliable behavioral change detection, and those failures invited exploration, as Richard Bradshaw would say. And the exploration drove understanding, both of the expected and unexpected behavior of our systems. And this combination of fast, reliable automation and deep skilled exploration allowed us to minimize the time and effort in achieving shippable quality for each new change, or in other words, minimize the transaction cost of getting changes into production. So what did we learn from our focus on what did our focus on testability achieve? So the design approach that we adopted was adopted by all the teams in the Cork office and across the US. The speed of delivery and quality of the product improved dramatically. Releases went from 7 weeks of that tortuous regression testing to a couple of days of exploratory testing. And the teams were able to work at a sustainable pace and were proud of the work they were doing. So after this experience, I had a profound realization. When I thought, this went on over maybe 12 to 18 months. And what I realized when I reflected on it was that the most significant improvements that we'd seen weren't driven by testing. They were driven by building relationships and influencing the right people at the right time to build quality in. So that brings us to the next leg of my journey, the operability leg. I didn't write this book. I started working with an early stage startup with about 20 people, maybe 6 software engineers. And we were a B2B SaaS-based company providing real-time online fraud detection. And the product was really beginning to get traction with some of the biggest retailers in the world. And this was a new context for me with a completely new set of challenges. It was the first time I'd worked on a SaaS product, but I quickly learned that because our service was on our customer's cart page, it was critical that it had to be available, responsive, and scalable to fluctuating customer needs. So, but building out robust automation and doing deep exploratory testing was only a starting point in this context. This taught me almost nothing about availability, responsiveness, and scalability of our systems, right? So I soon found that no matter how much testing I did pre-production, we still experienced problems when we deployed changes. And when I reflected on that, I realized that we were no longer simply testing code, but we were testing complex systems comprised of real users interacting with real data on real infrastructure. And we simply couldn't recreate the variety, volume, or complexity of production type traffic in our test environment. So the reality in this complex, with these complex distributed systems, is that if you're not testing in production, then it's your customers that are testing in production on your behalf and feeling the pain. So we needed to test where our greatest risk lived, which was production. So I reframed the CODS model to focus on operability, to make it safe to deploy and test in production. We did this by, firstly, control. We controlled the risk exposure. We began doing blue-green deploys, which allowed us to revert to the deployment quickly and easily if we detected an issue with minimal impact to our customers. O is for observing system behavior. We added instrumentation to visualize our critical customer pain points, error rate, response time, and the whole team monitored the system during our releases. D, we decomposed our deployments so that each deployment was limited to a single change set, which meant we could quickly isolate the source of a problem if an issue was released. S was we simplified the deployment process so we could deploy a rollback with a single click of a button and created runbooks to help debug issues in production. So this approach hugely accelerated the rate at which we could ship while also reducing the negative impact caused by any issues on our customers. And it opened my eyes to the power of deliberately testing in production and managing risk with operability. So one of the most significant testing challenges that we faced while scaling the company was having to replace our entire persistence layer, all our databases, in time for Black Friday. So again, we applied the CODS operability model when we were designing and planning the change. This time we decided to control risk exposure using feature toggles. We added a feature toggle to control whether we were writing data to our old persistence layer, the new persistence layer, or both at the same time. And then we also added the feature toggles to control whether we were reading data from the old persistence layer, the new persistence layer, or both at the same time. So to observe the system behavior, we added data consistency checks. So we added instrumentation so that when we had dual read toggled on, we would read data from the old persistence layer and then read data from the new persistence layer and throw an exception if the data didn't match. So this allowed us to do what's called a shadow release. So we deployed our new persistence layer into production straight away behind the feature toggle. We turned on dual write, so the new persistence layer had to silently handle our real production traffic volumes. We monitored its performance and addressed the issues we found without any customer impact. We then turned on dual read with verification. Again, we identified and fixed any data integrity issues using real production data without customer impact. A matter of weeks later, we turned on the new persistence layer before Black Friday with no issues, and the company was sold a matter of months later for 44 million euro. This again showed how a focus on operability can turn a hugely risky, complex change into a routine, controlled, stress-free affair. So here are some of the examples of the techniques I've used when designing for operability, again using CODS to manage risk. There are more than these, obviously. This is just a subset, but these are some of the ones that I was using at the time. So from a controllability perspective, we wanted to control risk exposure. In order to control risk exposure, we use techniques like using blue-green deploys, we use feature toggles, we use canary releases, and A/B testing. In terms of observability and observing our system behavior, we used alerting, synthetic tests, which are automated tests that run in production. We used logging, monitoring, and tracing. In terms of decomposability, we decompose our deploys down into single change sets, tiny change sets, so that a single change set was deployed per deployment. And then simplicity, we simplified the deployment process. So we have a single click of a button to deploy our rollback release, and we had automatic rollback on error rate spikes. So another lesson I've learned is that when it comes to operability, you have to go beyond just testing the production code. You need to test the infrastructure and tooling that supports operability. It's essential to resilience test your operability infrastructure. You need to test that your infrastructure and tooling will work when you need them most, which is when things go wrong, because inevitably things will go wrong. So you need to be able to recover gracefully. So this brings me to the observability leg of my journey, and we're on the home stretch now. This is one of my favorite slides. I just love the image, and it kind of sums up most people's approach to observability out there. But my last role before I started working here in Glowfox was as a quality engineering manager with Populum, again, another company based here in Ireland. I worked with all our engineering teams, enabling them to identify and achieve their quality goals. So having seen the power of designing systems with a focus on testability and operability, I shifted my focus from testing to coaching teams to build quality into the product from the start. So as a coach, one pattern I've identified is that of the 4 CODS operability attributes, observability is the first and most important thing that teams need to focus on when I begin working with them. Why? Well, observability allows the team to get a true understanding of how healthy their system currently is, how their system actually behaves as opposed to how they imagine it behaves. It allows them to understand the reality that their users are experiencing. And lastly, it allows them to identify where they need to focus their quality efforts. So observability starts with simple questions. And when I start working with teams, I ask these simple questions. How would you know if your system wasn't healthy? How would you know if your users were having a bad experience? In the event there was a problem, how would you isolate the cause? So what we want to do is we want to give our systems a voice, a way of saying, I'm healthy or I'm unhealthy. That's kind of a part of observability. So this simple technique of asking questions like this gets teams thinking about what aspects or attributes of their systems are really, really important. It gets them identifying and adding important health indicators using things like service level objectives. It helps them gain an understanding of what normal system behavior looks like so that they can identify abnormal system behavior. So once we have the fundamentals in place, we can extend these ideas across the business to understand the relationship between the various layers, right? So at the very base, right, and this is looking at observability holistically, I guess. At the very base, we have infrastructure, and we can monitor things like utilization, saturation, and error rates of our infrastructure. And if our infrastructure is working well, the next layer that we can look at is our services, and we can monitor things like request rate, error rate, request duration, and progressing to custom SLOs defined by the team. And if our infrastructure is working well and our services are healthy and working well, next we have the product itself. And we can monitor things like successful user tasks completed to understand whether they're being successful in the things they're trying to achieve with our product. And if the users are being successful in completing their tasks, the next things we want to monitor are our users, our customers' success metrics to understand whether they're being successful in their jobs. So that it's one thing to complete a task, but it's a different thing to be successful in your job. And if our customers can be successful in their job and whatever they're trying to achieve, ultimately, we can monitor our business success metrics, our KPIs, to understand the impact of unhealthy infrastructure, unhealthy services, unhealthy product, unhealthy customer metrics on our business metrics, and what impact it has on our business as a whole. So we can observe and look at that, at the observability of, in a holistic manner like this, from infrastructure all the way up to how successful our business is performing. So I believe that a well-observed system is both checked and explored. This may seem familiar. So we check the system for known failure scenarios, or knowns. Symptoms we know are indicative of customer pain. And we explore the system for unexpected behaviors, the unknowns. We explore the data looking for unusual patterns. So we check for symptoms or indicators of customer pain, and there should be a finite number of indicators. And in the case our customers are experiencing pain, we explore to identify the cause or the source of that pain. It's like when we go to the doctor. You don't go to the doctor and list all possible causes. We list the symptoms of the problems that we're having, and then we can explore once we understand, once we've talked through the symptoms. So by focusing on observability, we improve both the monitorability, which is our ability to detect customer pain, and the explorability, our ability to understand system behavior or the cause of pain of our production systems. So previously in Populo, we had low observability. We wasted most of our time in a sea of noisy, unreliable alerts and creating hundreds of dashboards for every potential cause we could think of. But more often than not, it was our customers that were reporting issues, not the alerts. And even when they did alert for genuine system outages, they only told us that we had a problem, and it was very difficult to isolate the cause of the issue. So the results of focusing on observability were that teams had a smaller set of better, more reliable alerts that were focused on identifying the symptoms of customer pain, not monitoring for cause. And when they alerted, we knew we needed to act immediately. So it was really reliable alerts that we acted on as a team. Now, the explorability allowed the teams to get a deeper understanding of system behavior and quickly slice and dice the data to get to the cause when there were outages. We could ask questions of the system without needing a release. So we could quickly slice and dice the data, say, oh, it's only impacting this type of browser in this location, or, so it was really easy to isolate the cause of problems. And these teams are now curiously exploring their production data. Like some of the teams do it as part of their stand-up, is they just bring up their dashboards and they go through them and they look at the patterns of the data, and they're even finding legacy bugs by identifying those unusual patterns in their production data. Bugs that otherwise would never have been found. So it's really interesting to see them exploring their production data and exposing problems live in production that way. So in many cases, these teams were now able to quickly detect system outages and correct problems before customers were either impacted or aware of the issue. So this was a big change from our customers were telling us that we had problems to a situation where we detected them, we fixed them before the customer was even impacted. Was a really great change. So great monitoring drove action, allowing us to quickly detect production issues, while great explorability allowed us to understand the cause of the problem through skilled, curious debugging. And it's this combination that minimized the effort in detecting and resolving production issues. So having seen how effective observability was with our software systems, I decided to try to build observability into our systems of work so that we could understand how we were performing as an engineering organization. So we adopted the Accelerate metrics from the Accelerate book by Nicole Forsgren, another great book to pick up if you haven't read it, to help guide us at a team and department level in our quest to deliver value to our customers quickly, reliably, and sustainably. Now, these indicators are scientifically proven indicators of high performance delivery teams. So the four key metrics are throughput metrics, firstly, which are the deployment lead time and deployment frequency. And the second two are stability metrics, and they consist of change failure rate and mean time to recover. So what I noticed when we did this was there was an interesting relationship between the Accelerate metrics and how testable and operable our systems were. Teams with low testability and operability were low performers. Their testing was slow and ineffective, and when they had production issues, the impact was huge on the team, the business, and our customers. By improving testability, teams made more informed decisions on the risks they could imagine or anticipate, reducing the likelihood of introducing a failure, allowing them to move more quickly with confidence. While by improving operability, it allowed teams to deal with the realities they didn't anticipate. Remember, failure is inevitable, so it allowed them to reduce the impact of failure when it did occur. So the combination of high testability and operability provided a hugely powerful mechanism for managing complexity and the associated risks. So again, testability reduces the likelihood of a failure, and a focus on operability reduces the impact of failures when they do occur. And this allows teams to produce quality software at breakneck speed. So focusing on testability drove throughput in terms of the accelerant metrics. So our focus on testability reduced the lead time for change and increased deployment frequency, which ultimately minimized the time and effort to ship changes to production. While operability drove our stability metrics in production in terms of reducing the change failure rate and reducing the mean time to recover. And these ultimately minimize the time and effort our team spent dealing with quality problems in production. So these combined, operability and testability, allowed us to achieve optimized flow by accelerating the delivery of value and minimizing the cost of poor quality. So although it may seem like it makes sense to always invest really heavily in testability and operability based on all the things that I've just talked about, I've learned that in some circumstances, it's not necessarily the best investment. So our deployment decisions have consequences ranging from, on the very left here, a crappy experience for our users. Oh God, that icon doesn't look right. To the loss of money for our users or our business. And in very extreme or unfortunate circumstances, it may even be life impacting. And understanding that context and the potential consequences of failure is critical. So we need to ask ourselves, what do we have to lose in this situation, and tailor our approach appropriately. For high impact, irreversible decisions, rigor is paramount. We need to invest heavily in both testability and operability to prevent failure and minimize impact. For example, if I'm writing software for a pacemaker, I want to ensure that I'm investing a lot in testability and operability. As I said, particularly testability to minimize the likelihood of failure, and operability to minimize the impact if it does occur. While for decisions that are low impact and reversible, oh, let's try out this new button, let's change the color of this, whatever it happens to be, we want to optimize for speed, allowing our teams to iterate quickly so that they can out innovate the competition. Remember what I said about Amazon and their ability to deploy a million times a year. So in Populo, for example, our lean approach to product development meant that sometimes teams were working on new experimental features, and other times on enhancements to business critical features. But teams were applying the same engineering rigor in both situations, meaning that we were investing huge amounts of time and effort in potentially throwaway experiments. So what I realized was that we needed a different approach depending on whether we were building to learn or building to earn. So this model that I'm showing here is the 3X model from Kent Beck. And I think I heard about it from Anne-Marie Sherritt initially, but it helps guide our investments by understanding which phase we're in. So when we're building to learn, which is on the very left over here, there's lots of uncertainty, but also a huge amount of opportunity. We're trying to figure out what product to build or what features to add or whatever it is. We want to do lots of small, fast, cheap experiments, and we want to optimize for opportunity cost, because as we know, 2/3 of ideas are wrong. In the explore phase, the more experiments we can do, the more we learn, and the more likely we are to find a winner. Remember the OODA loop. The faster we can iterate through that cycle, and the more cycles we can do, the faster we learn. So we invest as little as possible to test the basic functionality and to observe and control the experiment in production. Again, most ideas are bad, will fail, and we'll end up removing them anyway. And on the rare occasion that one of our experiments resonates and we achieve what's called product market fit, in other words, our customers or the market decide this feature or this experiment or this thing is really, really cool, and they all start using it, and it's the customer that decides that, not us, we enter into the expand phase. And when we go into the expand phase, we do everything we can to scale to market demand and increase our investments in testability and operability as a result. But we only do this when there's evidence the software is valuable. In ways, managing complexity doesn't matter until somebody cares. So there's no point in building the most robust, production-ready system in the world if nobody wants to use it. So once we've overcome our scaling challenges, we move into the extract phase. We begin to focus on return on investment and efficiency. Our customers now depend on this functionality. Therefore, we must invest really, really heavily in designing our systems to manage complexity. We need to be able to adapt our systems safely, and any issues or downtime are very costly. So we invest heavily in both testability and operability in the extract phase. So having talked through each of the significant experiences that have shaped my perspectives in software delivery, there's a clear pattern here, right? The most profound lessons I've learned in my career have come from the most painful experiences. As Ray Dalio says, pain plus reflection equals progress. So when you experience pain, take time to reflect and try to take lessons from the experience. Being part of a failed product taught me to take an experimental, evidence-based approach to learning. Experiencing the pain of working on unmanageably complex products that were painful to test and operate led me to discovering the value of managing risk by designing systems with testability and operability in mind. So, to come back to the title, if testing isn't the goal, then what is? Right? So, to deliver software that improves people's lives, I guess. So, software systems are socio-technical systems. They are created by people for people. So the goal is to deliver software that improves people's lives. We want to build things that matter, things that change the world for the better. But we also want to minimize the suffering caused when things go wrong. But we can't do this on our own. We can't focus on development in isolation. We can't focus on testing in isolation. We can't focus on operation or support in isolation. The huge leaps in productivity that I've spoken about related to testability and operability can only occur when developers, testers, operations, and so on work together. So I've begun to see huge benefits to working closely with customer support also in my current role. So the whole team is the unit of delivery. Therefore, we must optimize for the whole and not the parts. Our team, and to be clear, our team includes everyone involved in taking an idea from concept to customer. So in order to deliver value to our customers quickly, reliably, and sustainably, we need to cultivate an environment in which an amazing delivery team experience will emerge. A team experience focused on using learning as a weapon, continually learning through safe-to-fail experiments, focused on unearthing the right things to build and better ways to build the right things together. Investing based on evidence. Most ideas will fail, so we should only invest heavily once there is evidence that the change is valuable, otherwise it's removed. Using pain to drive better design. Continuously evolving the design of our systems to address the biggest pain points bubbled up by the delivery team. So the most effective way I've found of doing this is by visualizing, socializing, and optimizing for the whole team experience. Creating safe spaces where everyone involved in building, testing, deploying, and operating the software is encouraged to share their experiences openly and honestly. using events like incident reviews and team retrospectives to genuinely learn about our systems in a blame-free environment, where managers, developers, testers, UX, product operations support are all empowered to visualize the challenges that they face as a team, socialize the impact of those problems, both on in terms of the individual and the team as a whole. And then, most importantly, to give the team the time and space to work together to overcome their biggest challenges. Because if there's one thing that I've learned in the last 6 or 7 years of working in this complex new world, it's that when you optimize for a great whole team experience, you'll get happy, high-performing teams as a second-order effect. Because I believe that life is too short to build software that doesn't matter. And life is too short to have complex systems that fail horribly and inflict pain and suffering on our teams and our users. So let's, to quote Peter Senge, so let's build organizations and teams obsessed with learning. To quote Peter Senge, the only sustainable competitive advantage is an organization's ability to learn faster than the competition. And design systems together that can be safely adapted based on what we learn, so that we can be part of happy, productive teams working in successful, innovative businesses, delivering valuable software to satisfied customers. So my name is Robert Meaney. Thank you very much for listening.
Thank you, Rob. That was fascinating, even for me, and I'm not a tester myself.
I'm
sure others found it even more interesting. We have a question that Neil shared. Regarding the 2-quadrant model, was your route to success like 3 parallel arrows from lower left to upper left, trial left, and lower right, or were there more complex dependencies? Maybe if you can perhaps...
yeah, so there was a few quadrants I show there, right? So, so there was one quadrant.
Which one you were referring to? Perhaps we'll display it for people to visualize it, if that's okay.
Yeah, so there's a testability one, there's an operability one, and then there's a one that looks at both testability and operability. So I'm not sure which one. So to be honest with you, what I found was that when you focus on testability, for example, in that quadrant, it impacts both what I was talking about there is automatability and explorability. A focus on testability will impact both. So it's not an either or. So when we design our systems to be testable, it makes them easier to automate from an automated testing perspective, but also easier to explore from an exploratory or experiential testing perspective. So because when we design our systems that way, we have new interfaces. We have people designing it with a testing mindset in mind. So it helps both automation and the human side of testing. And it's the very same with operability. Is when you focus on operability, and there's 2 parts to that, which is monitorability, which is our ability to check for the symptoms of pain, and observability, which is our ability to kind of understand what's going on in the system through questioning it. When you focus on observability as a whole, or you get monitorability and explorability, both of those things out of that. It's not one or the other. And as I said, when you have great testability, when you focus on testability and operability, what that does is it gives you the tools to manage risk really, really effectively in your environment, because that focus on testability allows you to prevent a lot of defects getting into production. And the focus on operability allows you to quickly detect and react and fix problems if and when they do get into production. So overall, you're reducing the likelihood of the occurrence of a problem, and then reducing the impact of the problem. So I've kind of gone through the 3 models there. So hopefully, I'm not sure if it answers the question, but feel free to come back and ask again there if it's not clear.
Thank you. I think we have one more question, which I think it's the goal question, essentially, which is, Yeah, Neil, first of all, appreciate the answer for the previous question. And I have one which we got here as well, which essentially asks, okay, that was very insightful, but how do I get people to join me in doing that? I need management buy-in in order to be able to apply this.
Yeah, so getting people to buy in and apply this is not as easy as it sounds, obviously. And the key mechanism I use to introduce these kinds of changes are techniques I call a learning review, but in other places people might call them post-mortems or incident reviews or something like that. But we use learning reviews and retrospectives as the tools to drive this stuff. Why? Because if we have an incident, for example, let's say we have a production incident, and the team has just been through quite a stressful event, right? When you go into a post-incident review, or I call it a learning review because I like to focus on distilling as much learning as possible from incidents, if we can have conversations about the pain, about the pain and the problems that happened, and then can suggest things around testability or operability as a result, people are more open to experimentation and trying things when they've just felt the pain of a problem. So I find the best vehicle for introducing these types of change, even small changes, is ensure that when there are painful events, incidents, whatever, or really serious bugs, whatever they happen to be, is to do a review as a team and explore what we could do from a testability perspective or an operability perspective to first reduce the likelihood of this happening, or second, reduce the impact of these kinds of things happening when they do occur. And as I said, managers, developers, other people in the team are very much open to trying new things when they've just been through a really stressful scenario. If they believe this might prevent or help reduce the impact of it, they're more open to these ideas. And again, one thing to do is don't try and change the whole world. Take a simple thing and trial it and say, how about we just try this for a week? How about we try it for 2 weeks and try something, start small, start with a trial and see how it goes. And usually that's the best way to gain adoption of these things. Don't try and change the whole world, the whole way of working. Start with something small and something simple that you think will benefit the team.
Thank you, Rob, so much for this wonderful session. We got that feedback from some members as well. I see we have one last question. So if it's okay with you, we'll squeeze it in.
Yeah, go for it.
Okay, and then we'll wrap up. Jeff is asking, it says that there is a trend of package applications in the cloud. That means the ops team is the vendor in a way, and this leads to a lack of control, operability, and monitorability in a way.
That is a very interesting problem. That's true. So there's a compromise there, right? So by building on top of other people's software, whether it be libraries, whether it be infrastructure, you lose controllability and observability there to a degree. I've been through this myself. I've worked with some Amazon products that have really poor controllability and observability. And in one situation, we actually went away and rebuilt it so that we could actually, so we built something. It only took a couple of lines of code to build this piece of functionality using a library provided by AWS. And after trying to debug an issue for 2 to 3 weeks, we went back and actually wrote it ourselves so that we could actually have the observability and controllability we needed, because the time it was taking us in terms of maintaining and debugging the application was huge. So by taking it out of where it was and actually building it ourselves with the adequate controllability and observability, it meant we invested, say, 2 weeks of dev time to allow us to very easily test and operate it ourselves and see when there were problems we could, as I said, debug, investigate very clean, in a very clean way, because we had control of the instrumentation and all that kind of stuff. There's no simple answer to that question. When somebody else builds the product, the only thing you can do is work with the vendors. Ensure that you first of all have good instrumentation at the boundaries of your system, and then work with the vendor to try and improve your observability and controllability of their system. Cool.
Yeah.
And if anyone has any more questions or is interested in anything I have to say or anything, I have my Twitter handle is Rob. It's down here. It's Rob Meaney, at Rob Meaney. Go on Twitter, ask me a question, or LinkedIn as well. It's just Rob Meaney on LinkedIn as well. I work for GlowFox. Connect to me on LinkedIn or Twitter. Ask questions. Or if you want to get on a call and talk further, just reach out to me. I love talking this stuff, as you can probably tell.
Thank you, Rob, for this wonderful session. Thank you, everyone, for joining us today. We'll be sharing the recording. We have co-workers that could not join us today. I know some people message us that they could not join, but they are interested in hearing you speak. We got a lot of traction with your big title, but I think you stood up for the session to fulfill such a large title. I hope everyone enjoyed it. Have a good rest of the day, everyone.
Thanks, everyone.